Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. And we're very excited to host today's event, Masterclass, Getting Started with AWS DevOps. And presenting today's topic is Terumi. Terumi is an Amazon AAI training consultant and author holding more than 25 years of experience in IT. Her passion for cloud computing developed at a very early age. Being a teenager, she always showed her enthusiasm for understanding the technologies that make computers tick. This deep sense of curiosity on technology led her to achieve all the associate, professional, and specialty certifications and was recognized as an AWS Authorized Instructor Champion. Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. In this event, we'll learn the basic practices to help your team master the most common DevOps patterns, practices, and tools required to develop, deploy, and maintain applications and services at high velocity on AWS. And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Terumi, thank you so much for joining us today.
Hey, thank you so much for inviting me, and hi, everyone. And thank you so much for that introduction, by the way. I hope you can hear me okay. And also, I'm kind of sharing my screen right now. Can you see the screen okay as well?
Yes, you are audible, and we can see your screen. Everything looks great.
Great, thank you so much. As I say, hello, everyone. In fact, let me just say aloha. I'm in Hawaii right now, and this is my pleasure giving you the masterclass. And the title of the class, of course, is Getting Started with AWS DevOps. And by the way, this webinar will last, it actually has a couple of sections. So if you have any questions at all, please, feel free to post your question anytime at all, and I'll definitely get to them, when we have the time for that, okay? So let us get started, okay? Today's session, as you see, is on DevOps, right? And it's specifically on AWS DevOps. So let me show you the agenda for today. There are 5 sections within today's webinar. The very first one is a foundational topic. So it is a foundation of AWS DevOps and AWS DevOps services. So I will be covering what is DevOps. That is, regardless of any type of a cloud vendor and such, I'll introduce to you what DevOps means. Then on the latter half of that, I will introduce you what AWS means by DevOps and some of the services that they have to offer for you. The second topic is I thought it might be nice for not just to hear about the concept, but to actually see DevOps in action. So I have a sample project ready for you that you can just go and follow along. And it's called the Unicorn Wild Rides. So it's like a little Uber, but instead of a car, a unicorn will come and get you, right? So that's going to be the application that's actually created by AWS. So it's available if you like to do it on your own at a later date. And within that demo, there are a couple of sections. So the first part is the DevOps. I have in here workflow step 1 and step 2. So this is the very first step of DevOps, which is to specify the source control service. And then we'll talk about something called the artifacts that will come in my first part of the discussion. The fourth part is step 3 and 4, which is arguably the very core of DevOps process, which is the build phase and the deploy phase. Then on the last one, this is where you actually get to see the end product of DevOps, which is the pipeline phase, okay, and actual deployment and automating the whole process. So there you go. So that's going to be agenda for today. All right, so let us go ahead and get into the first part, which is the foundation part. Okay. Here. All right, so here we go. Just to get started right from the beginning, right? What is DevOps? Okay, so there you have it in front. Right? Let me go ahead and read that for you. A set of practice that combines software development and IT operations to streamline and shorten the SDLC. Okay, now, if you are familiar already with development process or operational process, this may sound okay to you. But if you're brand new to the topic, you may say, but what's DevOps? What do those terms mean? And also, what is this thing about software development, IT operation process? What does that mean to combine them together? Like, how come they're not together already? Or maybe you may have some questions about what is this SDLC thing, right? And why do we need to shorten the SDLC? Okay, so we'll definitely cover that part. So kind of keep this on the back of your mind, and we'll revert back to this definition a little bit later on. So first thing first, let's go ahead and talk about what this SDLC thing is all about, because that seems to be key to this definition. So SDLC stands for a couple of meanings. Some people call that software development lifecycle, right? So SDLC. The one that I have in front of you is systems development lifecycle. They're just a little bit different, but not too much, right? And the reason why I chose systems development lifecycle because it actually includes more parts, where you have the step 1 and step 2. That part sometimes it's not part of the software development lifecycle, but I just want to kind of show you, what a company may go through when they are trying to come up with a new product, new software product, right? So let me explain briefly. When a company endeavors to create a new product, right, you have to kind of consider the reason why are they doing that. Well, hopefully it's for their business, to increase the customer base, right? To give better products to their existing customers, etc. Right? So it should be a business reason. So there's going to be the systems requirements document that states what a product's supposed to look like. Then when it comes to IT, information technology department, now they have to turn that business needs and wants into something that is a systems needs and wants. So that would be a systems requirement document. That's why we have step 1. Then someone will take that requirements and then create a architectural design from that. Right? So those are the very first steps that one takes in SDLC. Then once the architect has finished with their design, usually that's passed to a development organization. Now the development organization could be programmers, it could be people that purchases software and integrates them with existing software. Regardless, it's where they create that new product or new service. Then, before that could be given to a set of customers, it needs to go through some rigorous testing. So that's called the QA testing or quality assurance testing. Then after the product passes the quality assurance testing, then now that is ready to be deployed or made available to what's called a production environment. So production environment is the actual environment where the customer will be using it, right? So if it's a internet site, sure, right? Put that new product out on the website so that all the customers have access to it. Okay. Then after that is online, in production, ready to go, people are using it, then someone, normally the operations people, will have to maintain that solution. Maybe they'll have to patch it, they may have to make some tweaks, changes, right? Listen to the customer and see how the application's going, right? So those are all the things that are included in the operation. So that is the very short description of what an SDLC is. So I have in there the red arrow that says combine. So this is the part that the DevOps is trying to streamline. Okay? So anything that created in the development phase, all the way to where it's being made available to the end customers. This is the process. This is the portion that DevOps is trying to do. Make it streamlined. But we'll talk about why that is the case. But as you see, there are 3 points on the right? So DevOps is a culture where development, the QA departments, operations team work together. Okay, so we'll talk a little bit later on in about a couple more slides why they're not working together in a lot of cases, right? But if you're trying to streamline stuff, right? Streamlining means going to the minimalist option, getting rid of all the frills, bells and whistles, so that it can go fast. Okay, so all the different people that you see on the SDLC, they need to work together so that there are no barriers, there are no excessive friction as the solution moves from one stage to another stage. Okay. So that would be, we're talking about the culture. I'll have a couple of slides on that. To streamline SDLC using Agile principles. Now, some of you may be familiar with what an Agile is. Agile is a concept that came up around early 2000. I think it might have been 20. I would say, yeah, without naming the actual year because I may get wrong on that one. But it was in the early 2000s where a group of people came together and said, look, the way we do software development, it takes too long. It is just too cumbersome, too heavy. So let's make it light. And let's make it fast, right? So the commonality here is streamlining that is making things fast. And last but not least, and this is the part that we're going to be spending a lot of time on this webinar, is to automate, right? So to automate development through deployment process using what's called the CI/CD. Just a quick explanation of the term. CI stands for continuous integration, and CD stands for continuous deployment or continuous delivery, which I have a whole set of new slides over. But just at this point, just understand that CI/CD has something to do with automating this whole process, the step 3, step 4, and step 5. Okay. So anyway, so that is DevOps, and there are mainly 3 concepts that are involved with it. Okay. Like I said, if you have any questions, just go ahead and put it in the chat. All right. So now we have some kind of idea as to what DevOps is. Okay. But why do we do that? Okay, so why do we have to make things faster, right? So, and here's the thing: the goal, right, of the DevOps is the following: to increase the velocity of deploying software to production. And put it another way, when you create something new, make sure that new feature or new solution gets to the hands of your end customers as quickly as possible. Okay, and I can attest, I've worked in project management before, and I've been involved in projects that took like months, if not years. Okay, so that's like, okay, so someone come up with a good idea, they make a request to the IT, and it takes like months for that thing to be done, and for the end user who asked for it to actually, play with it and start using it. Well, in the time that we live now, that is just way too long, right? And so why do we want to make it fast? Why do we want to increase the velocity of this whole process? Right? I've pretty much written in there 3 points. Customers get the newest feature faster, so that means customers will be happy, I hope. Okay. The next one is the businesses side, right? Because after all, businesses are the one that's paying for this development, and they can get ahead of the competition. Right? Because I think a lot of the companies are living in a world where there are competition, where they're fighting for the same group of customers, and the more you satisfy and give customers a great experience and great products and services ahead of the other guys, right? That you will be ahead of the competition. And then I'll put that third part in there. Developers can innovate more. And that may not be as straightforward as what you may think. Like, why is it making the development process faster, right? Is going to give developers more time to innovate. Okay. So once again, I'll cover this, but this is actually really an outcome of DevOps as well. But anyways, I think the first 2 points are pretty easy to understand, right? So that's why a lot of companies these days are taking on the DevOps practices. All right, so let me go a little bit more into some of these terminologies. Okay, so we talked about the culture, right? So now let's talk about culture. I have a couple of slides on this. So on DevOps culture, and I mentioned that it's about being agile, right? Or taking in agile principles. So here I have a short definition of what an agile framework or like a blueprint, right, on how agile is applied to DevOps may look like. Okay. So the first one is a iterative product development methodology. Okay, so iterative means you're repeating things over and over and over again, right? And it's usually, when we say iterative, we're not talking about the first cycle going through like it takes like a year, right? It doesn't take like a month, okay? So iterative means short period of time and you are producing something, right? Because it's a development methodology. And because it is normally a very tight loop that you go through, the amount of development that you can do is also limited as well, right? So it's not, in a traditional, the kind of like, let's say, financial organization creating a new application, I've seen cases where they had like hundreds of people working on it. Yeah, like hundreds of developers, and it was taking literally like months, maybe if not years, to create this big product. Well, that is not going to work in the Agile framework, not that well anyway, okay? So the teams have to be smaller. The actual software product have to be smaller so that the process takes shorter, and then instead of taking months, you'll start to deploy things in small chunks. Okay, so that would be the iterative product development. And as I mentioned, it's usually small teams. Okay? And what's important here is a cross-functional teams. So cross-functional team usually means, okay, what does that mean, right? Because in development, you've got developers. What kind of cross-function do you have? And actually not, right? Developers are developers. That's not a cross-functional team. So the cross-functional team usually means that you have other people with other expertise in your team. So for example, maybe a QA tester, quality assurance tester may be in your team. Maybe systems operations person may be in your team. Maybe security people may be in your team. Or maybe you're yourself, let's say if you are a developer, you have been trained, let's say in security, or you have trained in systems operations, so that you have skills in multiple areas, not just development. Okay, and these jobs that I just mentioned is all part of the SDLC, if you remember, right? Some of the people that kind of come together in the SDLC. And last but not least, producing the MVP, right? So the MVP stands for minimal viable product. And minimal viable product refers once again to small piece of product, code, program, whatever you want to think about it, that actually stands alone. That is, it can do anything it needs to do all by itself. So that's usually what an MVP is. Okay, and I have in here incremental sprints. So the sprint is the process that I told you about, the iterative process. They're usually called sprints in agile methodologies. So there you go. So these things you'll see in a lot of DevOps being applied. So that is part of the changing of the culture when companies are moving into DevOps culture. So the second part here is this. It has a something to do with that cross-functional team. Okay. So if you take a look on the left, right, where I have from this. Okay. So under that, I have two sets of bunch of groups of people, right? So one is the developers, and the other one is the operations folks, right? And it's very common. I've been in IT for a kind of long time, and it's very common for these development and the operators to not get together, right? So it's not that they don't like each other. It's just that they have complete different sets of jobs, right? Developers create things, and operations people maintain things. And there was really no major push to bring these two groups of people together. So I'm sure that in a lot of companies still this way. They're highly siloed, and they're used to working on their own, not together. But with DevOps, the culture has to change. So if you see on the right, you see the comment of Mr. Jeff Bezos, the CEO of Amazon, saying, "Hey, if you cannot feed a team of developers, right, with 2 pizzas, it's too large." Okay, so you hear in the AWS DevOps practices a term pizza teams or 2 pizza teams. Okay, so what a 2 pizza team is exactly that. That's how large your development team is going to be. Okay, remember the cross-functional team, right? So that development team needs to be around 4, 5, 6 people, no more, right? Just enough to feed for lunch. Just order 2 pizzas, and that should be enough. So once again, the culture is smaller, right? And then cross-functional. So within these 2 pizza teams of these, 4 or 5 people, they are all cross-functional members. Okay, they're not going to say, "Hey, I'm just a developer here, right? So I have no idea what security is doing. So that's somebody else's job." Well, that's not the idea of a 2 pizza team. So everybody is able to hopefully be able to at least be intelligently talk about, let's say, security, talk about testing, talk about operations, even if your main expertise is in development. Okay. All right, 2 pizza teams. Okay, so now you know what that is. And so let's go into the next concept, which is streamlining. Okay, so streamlining looks like this. So once again, if you look on the left-hand side, it's from this to the right, okay? So from this states that you have 2 separate teams. You have the development organization, and then you have the operations organization, right? And a lot of times, in my experience, there is definitely an organizational wall, okay, that is between these 2 groups, because 1, they're under the different management, and 2, there are different mandates that they, their jobs are completely different. And 3rd, oh, by the way, I probably didn't tell you I have a security background. From security perspective, we wanted these people to be separate, right? We wanted them to be separate for conflict of interest purposes. We want to keep any irregularities that may happen in development organization to not bleed into the operations and vice versa, right? So it was for accountability purposes, it was for responsibility purposes, that it was easier to manage these 2 groups if they were completely separate, okay? But that is really not conducive to speeding things up, right? Because more separate you are, more coordination you have to do. After all, developers are the ones that's creating the product, and the operations are the people that has to run the product. So how do you pass this end product from developers to the systems operation, right? So if you have the organization wall, the way I kind of refer to this, let's say software as being like a hot potato, right? So the developers finish with this hot potato, right? It's nice and piping hot, and it's too hot. So they'll toss it across the wall and say, here you go, okay? And then on the systems operations side, they're waiting for this hot potato, and that catches that, and says, okay, well, that's kind of hot, kind of fumbles around with it, and then puts it on the operations. So that's not really an efficient way to, to transfer the responsibility of one product to another, right? Another group. So DevOps seeks to take away these barriers, so take away most of the organizational walls, if they can, completely. And then the main point here is to reduce the friction between these two groups. But what are we reducing the friction of, right? Well, you're actually reducing the friction so that that hot potato, right, that can actually flow right from one organization to another, right? So that there is no process, procedures, time wasted as the developers finish with this product, that they can go smoothly into to the production environment, which is in the operational environment, right? So what we're seeking in DevOps, and you may not get there right away, is what you see on the right-hand side, which is the development team and the operation team actually being in one team, the two pizza team, right? And then working on the same goal at the same time as a one team. That's what we're looking for. Here, you have no barriers because look, they're all in one team, okay? All right, so that is the streamlining. And let me get to the third point, which is pretty important here, which is automation. Okay, so automation, I think, a lot of people know, right? It's pretty natural. Automation will take normally a lot of human factor away from the whole process. And not to say that, we all need to kind of take away the, the person in the middle type of stuff, but, humans are really good at, people, right, are very good at, innovation, right, coming up with some brand new ideas. But, I'm not sure if we are that efficient if we're doing repetitive tasks. Right. So if we're doing something that's repetitive, right, it probably doesn't really require a person. So let's go ahead and automate that. So we could take the negative part of having a person in the process, which is like making, I usually call it the fat fingering stuff, making mistakes, making like, dumb mistakes and stuff. All those things will go away. And you could run this iterative process, right, in a very standard manner, in a very, very fast manner, right? Streamlining, making it quick, increasing the velocity, everything kind of goes towards automation. Now, in DevOps, the automation has a special terminology. It's called CI/CD. Okay. Remember, I already mentioned that once. Continuous integration, continuous deployment. By the way, the D can also be delivery. So I actually have a next slide. We'll talk about that. So it's a set of practice for automating development, testing, and deployment of application. Oh my goodness, look at that. That's a SDLC, right? So that means CI/CD is a way for one to automate the whole SDLC procedure. There you go. Okay. All right. So in taking a look at another way here, you have I laid the SDLC on the side this time, right? And now the software development lifecycle goes from left to right. And I've added a couple additional steps in the SDLC that you may see. Okay. So maybe, this is actually the difference between systems development lifecycle and software development lifecycle. I've actually switched it, right, to software development lifecycle, right? So here we have the CI, which is continuous integration. So CI part is normally the traditional developers, what they would be doing, okay? So that means with the continuous integration, the developers are creating continuously new pieces of code that must be integrated with other parts of the code. So maybe there are other functions that must be integrated. That is, integrate means to, bring two things together or bring multiple things together, right, as one piece. So the functions that's happening in the continuous integration is the developers will finalize their code and they will what's called commit, right, to that code. And once the code is committed, the developer is saying, okay, I'm done with this part. This can be, tested, and, if given approval, please deploy it, right, to production. So that's basically what the developer is saying in the CI phase, right? So in the CI phase, the developers would do their testing, and some of their testing would be something like, unit testing is a very common one. They may do integration testing, functional testing, right? So in the development world, there are different types of testing that the developers can do. So that's going to be done in the continuous integration part. But that the continuous integration is over when there is a nice little package of software that's ready to be deployed. Okay, so that's how you know that continuous integration is over. So at the CI phase, you should have what's called an artifact, right? So the artifact is a package, right? So if it's a Java program, it will be a jar file or WAR file. If it's a Python, maybe it's a zip file that's been packaged, but that's called the artifact. So once we talk about CD now, I have two, right? So you have continuous delivery, and then we have a continuous deployment. Okay. So let's take the continuous delivery. You choose one or the other. Okay, so continuous delivery, notice it actually takes you right from the source, which is where the continuous integration was, all the way to the end, where you have a deployment and then testing to make sure that everything was deployed. So here, ideally, we're talking about the production environment. Okay, but right in the middle, right where it says deployment, you have this little human there. Right? It says stop. Okay, so this is where you have a human in the loop that almost everything's automated, except right at the end, before your product is ready to go into the production environment, you have a person or a team of people that will look at it and say yay or nay. Says, okay, I think this is ready for production, or no, I don't think this is ready for production. I think we need to tweak a little bit. Okay, so this is where you still have a person in the middle. And I hear that a lot of companies are in this model, which is continuous delivery. Okay, but for some companies, this is still too slow. It's still, there's just a little bit more, there's friction because look, there's a person in the middle. So they'll go for and opt for something called continuous deployment. So continuous deployment is from the beginning, from the source stage, all the way to the production, everything is automated. Like I said, I'm not sure if any company or if a lot of companies are in this stage. I don't think so. Not from the survey that's been taken by AWS. I believe about 80% of the customers that they've actually interviewed said they're doing continuous delivery rather than deployment. But if we're looking for maximizing and really stay in the theme of DevOps, then the eventual goal that we're looking here perhaps is continuous deployment. Okay. Anyway, so why is automation good? I think you probably intuitively know that automation will make things faster. So definitely CI/CD benefits are increase in velocity. Okay, and because remember, we're working on smaller teams with smaller piece of code. And remember, on the Agile, we do iterative processing. So here, it's actually frequency of deploying application to production. That means you can have, a bunch of little iterations and everything will be automated. So as soon as you're done with and commit the source code, boom, right? The automation, the CI/CD takes over. And if you're doing continuous deployment, everything's going to be automated, including testing, and then your product is going to be on, your end users are going to be using your product like right away, right? Maybe even multiple times a day, okay? So I've heard some companies doing that multiple times a day too. Now, it improves code quality in general because you're doing iterative development, so that means you're making iterative changes. So that means you're making smaller changes, and you're able to handle, let's say there's some kind of a mistake in the code, you should be able to handle that quickly and fix it, very quickly. Whereas if you have a humongous piece of code, which is usually called a monolith, and it took you like months and months to create it, what if there's a mistake in there? What are bugs in there? How will you find the bugs? In midst of like millions and millions of lines of code, it's hard. Okay, so if you have smaller piece, hopefully the code quality is going to be much better because they're smaller, and you can get to the problems and find them easier. Okay, and then last but not least, improves efficiency because it improves efficiency in that now you are deploying incremental changes, incremental improvements to your code. Okay, and you actually don't have to wait, right, for all the people, dozens of people to approve whether it's okay for you to deploy this code. Smaller piece, smaller team, they're totally responsible normally, so that they can go ahead and improve it and then update it whenever they feel it's necessary. That usually goes hand in hand with DevOps. Okay, so there you go. So that is the DevOps automation. Okay. And now I want to kind of introduce to you, now that I've kind of went over 3 of the core characteristics of what a DevOps is. Remember the culture part of it, right? Streamlining part of it, and the automation part of it. There are 3 other supporting technologies, procedures that I would like to introduce to you that actually supports the DevOps process. Now, these are not necessary for DevOps, but they're very, very helpful. So let me talk about the first thing here. First one is called microservices. Okay, so from the name of it, it says, okay, micro, very small, right? Services, yeah. So services here, we're referring to your application that you're deploying, right? So here it is, the definition: discrete, reusable application functionality which work together as a whole. Okay, each can be independently scaled and improved, right? So from this, what I want you to get here is that a lot of the companies currently are developing what are called microservices because they are a small piece of code that is just big enough for, guess what, right? 2 pizza teams, okay? So 2 pizza teams and microservices go well together, okay? And these 2 pizza teams can be independently responsible for their microservices. That's why they can go ahead and decide when they want to commit the code and then to deploy it in production. But because they are smaller pieces of bigger, let's say, business function, that these microservices will probably have to work with each other, right? So anyway, so that's called the microservices. Microservices has been around for a while now, right? So if you're familiar with something called web services, microservices and web services are akin to each other. All right, so the next supporting concept here is something called infrastructure as code. So you know that the application is code, right? So when we create application, we create something usually called source code, right? So the source code needs to be compiled, right? We call that building process, okay? And then once you compile it, you have something like, something.exe file, something.dll file, right? So those are the programs that you actually run, okay? So I think it's pretty clear, right? Application, right, is code, right? But what does it mean to have the infrastructure as code, right? Because infrastructure, for me, I've been working like many years on networking, setting up servers, right? Setting up Windows servers, setting up Linux servers. That's infrastructure, isn't it? Put in security devices, like, put in firewalls and intrusion detection systems. Those used to be like boxes that I have to plug right into the network. That's infrastructure. So what are you talking about? Infrastructure as code. What? Okay. Well, these days, starting from so a lot of years ago still, maybe 10, I would say, probably close to not quite 20 years, I don't think, where virtualization became very popular, right? And companies in their own data centers start to use virtualization, like, VMware and stuff, to say, yeah, I have servers here, but these are virtual servers, okay? All right, then. So if a server, a physical server, becomes a virtual server, the virtual server means that, it's not a real physical server. It's actually an application, right? So it's an application that's kind of acting like a server. So if it's an application, guess what? It's code, okay? So infrastructure as code refers to the virtualness of a lot of things that we do these days, right? So it's a virtual, it's a virtual network. Another way to say is logical, right? Logical network, logical servers, logical security devices, right? There's no physical boxes to kind of, throw around, okay? So this is a supporting technology that is very, very helpful in speeding up the process, because you can handle infrastructure, right, like another piece of program. Anyway, so once you have infrastructure as code, you're defining the infrastructure components. These are called resources inside a piece of text file, right? They're usually in a JSON format, YAML format, right? Just specialized notational format. Then you could say, hey, please, can you kind of launch a server for me? Can you launch a network for me? So you can provision logical infrastructure based on piece of code, right? Which is that, the JSON file or YAML file that we're talking about. And guess what? You can manage these infrastructure like another application code. Yeah, put it in a version management. Get a version 1.1 of the infrastructure. Get version 1.1 of the infrastructure. Get version 2.0 of the infrastructure. There you go, right? So that's the second supporting technology. And last but not least, the cloud, right? The cloud computing. Now, cloud computing, so this is, today, of course, we're going to be talking about AWS, but, cloud computing in general is application services offered via the internet by cloud service providers, right? Or you can have them on premises, that is in your own data center, if you have something called the private cloud, okay? Or you could combine them both, and that's usually called a hybrid cloud, okay? So anyway, so cloud computing actually makes it really easy for companies to virtualize everything, right? Right. So instead of saying, oh, I have these, I have like 10 servers and I have a network, it says, okay, we could recreate the same thing, let's say on AWS, but they're all going to be logical networks and logical servers, right? So it's easy to make that transition from the physical to the virtual. Okay, using cloud computing. And obviously there are tons and tons of other benefits of moving into cloud computing, but there you go. So those are the three support technologies, concepts that actually assist in DevOps. Okay. So here I want to kind of switch gears, okay, from here. Now I would like to go in and start introducing you to, well, how do we do all this stuff? I mean, it sounds like DevOps sounds like a great idea, but how do we do this in AWS? And what are some of the services that are offered in AWS that's going to actually help me do this? Okay. Alrighty, so let's go and take a look. So here I have titled AWS CI/CD Technology Stack. Okay. So right on the top in blue, you see the SDLC. Okay, so you see the code, the build, the test, deploy, provision. Okay, once again, a little bit different. Okay, I've added a couple of things where it says deploy and provision. Okay, but and what underneath are some of the services, not all, right? Some of the services that you would map to AWS services. So let's go and take a look from left to right. Okay. So under code, that would be code management, okay, or sometimes we call it, version control, okay, where you're updating the code and making sure that everybody understands what version it is. Is it version 1? Is it version 1.1? Is it version 1.1.2? So for that, a lot of companies will use something called GitHub, okay? Well, the GitHub is a third-party version management system and software. So something like it is provided in AWS. It's called a code commit. Okay, so code commit. So they kind of fit into the same genre, okay, as GitHub. Now, during the build and test phase, there are some very popular third-party services and software. One of them that comes to mind is Jenkins. So if you're familiar with Jenkins, it's an open source, what's called a CI or continuous integration server that will help you in doing and automating the build phase. So the build phase usually like, doing some testing, compiling, creating packages, okay? And at the end of the build, you should actually get an artifact. Remember the artifact? Ready to go, in production, right? So that piece of like an executable file. Well, AWS actually has this product or service, let's say, called AWS Code Build, right? So Code Build will help you build, okay? And also to help you test as well. So that's that piece. Moving on, deploying. So that's a pretty important piece, right? That, now you have the artifact needs to be deployed. So let's say a server, if you have, Kubernetes or containers into containers, or if you are using something called serverless in AWS, they're called Lambdas. You're deploying to any type of an infrastructure or the platform where your end user users are going to be using it. Okay, so there is something called AWS Elastic Beanstalk. Now, Elastic Beanstalk is a service that assists you in deploying a web-based application, right? So let's say you have a 3-tiered traditional web-based application with the front end, the middle tier, and the back end. Elastic Beanstalk will make it really simple for you to deploy them based on the AWS best practices. That has monitoring, it has logging, it has load balancing, it has all that features come in. So if that's what you want to do, Elastic Beanstalk will help you to deploy that. Okay. But if you want to be a little bit more free about the type of the the design and the platform that you want to deploy into, there is something called a cold deploy, as you see right under the Elastic Beanstalk. Okay, so cold deploy is going to assist you in deploying that into production. Now there are different platforms that you can have. So I have in there, user managed EC2 instance fleet. So I have in there CloudFormation. So there are many ways that you can deploy. So AWS gives you many options. Right? The one that you're going to be seeing is cold deploy, but there are other ways of doing it today. Then remember, automation is so important in DevOps, and all the tools like code commit, code build, code deploy, they're all individual services that will do their job all on its own. But the power of the DevOps comes in when you combine them all, right? To organize and orchestrate them all into one smooth process, where artifacts, your code is moving from one to the other and to the other, all the way to the end where it goes to production. Okay, and that orchestration piece of service is called the code pipeline. So you see underneath it all, it kind of covers the entirety of the SDLC. Right? So there you go. So these are the services. Now, if you are more interested in individually, what these services are, I'm going to kind of quickly go over and show you what an AWS page looks like for each of those services. So first, let's talk about code commit. Okay, so there it is. As you see on the left, you see the application and developers. And notice that they are using some kind of a client. So in this case, you could use something like a Git client or IDE, integrated development environment. Then that code is committed to AWS code commit. Okay, and their files encrypted. It'll scale. That is, you'll have enough power to do whatever you need to do. AWS, this is fully managed service by AWS, so you don't have to set up any servers, right? And that's basically called code commit. Okay, and notice on the right hand side, this is almost like a gateway, right, into the rest of the services. As you see there, you have code build, code pipeline, other CI/CD systems, right? So this is actually like a doorway into this whole the automation, let's call it pipeline, okay, that we're going to be talking about, which is DevOps. Next one here is code build. So code build, once again, you have code build, which is going to be building, okay, your code, right? Building your artifact. And it says, bring your runtime environment. So it's very flexible. Basically what this code build does is that, let's take, for example, something like Java, right? So you give source code to code build, and you tell code build how to make it into an executable, right? That is, in case of Java, it's going to be called something called a bytecode, like a jar file, the WAR file, right? So that's what you're talking about. You tell code build what commands they have to use, right, to create the jar file, for example, right? What tools do they have to use? And what code build will do is it will actually launch a container, Docker container, and then take your software, the source code, then it'll do all that stuff that you tell it to do. It'll do linking, compiling, it'll create a package, right? That's basically what a code build will do. At the end, now you have an artifact, remember? And you take the artifact and you store it someplace. A very common place to store it in AWS is Amazon S3. Okay, so that's what you see way on the right-hand side, you have Amazon S3 integrating with code build. All right, so the next service is code deploy. Once again, code deploy is, just as the name said, it's going to deploy into staging area, it's going to deploy into testing area, it's going to deploy your application into production, right? So that's its main job, right? So as you see on the right-hand side, you see EC2, so that's a virtual machine, ECS, so that is Elastic Container Service, so that would be, your Docker containers. Lambda would be serverless, okay? And other platform that you can take your artifact and deploy into. And code deploy will make it very simple for you to do that. It has options such as in-place deployment, where you are updating your code. Maybe you have you already have 1.0 of your application running, and you want to change that over to 2.0. Code deploy will make it, relatively safe for you, right? To actually deploy the new version on top of, let's say, the old version, or if you feel that that's risky, right? Because you are changing the version, you're kind of overwriting it. You may say, I think rather than doing that, I'd like to do something called blue-green deployment, where you have two environments, the old and the new, and then at some point you switch from one to the other. So that's much safer, and you can actually tell code deploy to do that for you. Okay. So there you go. So that'll be code deploy. Now there's one more service that we're going to be using, something called code artifact. Now code artifact is a service that you'll see in the demonstration as well, that actually allows you, right, provides secure way to manage artifacts. Okay, but I'm not talking about the artifacts that you create. Right, so these are the artifacts, or let's just say other people's programs that you need, let's say, for building stuff. Okay, now in our example, we have to compile a Java application, so we need a tool called Maven. Now Maven is an open source tool, but what if that open source tool is not available when you need it, right? Maybe there's an internet problem. You never know, right? So if you want to maintain stability of your pipeline, okay, maybe you want to actually have those tools elsewhere, like maybe somewhere inside AWS, right? So that you don't have to mess with any kind of irregularities that you may have in the internet connecting to that external service that you need to download the tool to actually do your building of your application. So we're going to be using AWS Cloud Artifact in that way. That is, we're going to kind of, put those external applications inside AWS so that you have a more stability in accessing those tools. So that's called Cloud Artifact. Okay. Notice on the right-hand side, it actually integrates nicely with Code Build. Okay, and last but not least, code pipeline, right? So this is like a conductor, right? In the orchestra, it'll take all these tools that we just talked about, like code commit, code build, code deploy, and then orchestrate the whole thing so that you don't have to. Okay, so there you go. So code pipeline, we'll see at the very end how it works. It'll just bring everything together. Okay. Now, here I actually do want to give you a very simplified view, okay, of what the code pipeline does, right? What the workflow does, right? So on the left-hand side, you see something called a trigger. Okay, so the trigger is what kickstarts this whole automation process. That is, kickstarts the CI/CD process. Okay, so what kickstarts it? Well, it's whenever there is something new to be deployed, right? So whenever a developer says, okay, I'm done with this, I'm going to push it into, let's say, code commit. That triggers it, right? So that's why the trigger is starting at the source, the code commit. So let's just assume, okay, we got a new piece of code in there, and boom, the CI/CD process said, well, there's a new code inside the source in code commit. Got to get started. Okay. Then the source is stored someplace. Now, it could be in S3, it could be in code commit, it could be in any places. By the way, just behind the scenes, code commit actually uses S3 behind the scenes, so that you know. So you have a output artifact that is a source code from let's say from the source inside some storage. Okay. So the next phase that is then to build, isn't it? So the pipeline will trigger and says, hey, there's something ready to be built. Okay, and notice I have a little kind of call out on the top. It says instructions, right, on how to build stuff, right? And it's in a file called buildspec.yaml file, right? Buildspec.yaml file. So buildspec.yaml file tells code build what to do. What command do I need? What am I building? And where am I putting that after I'm done, compiling it, let's say, or creating a package. So notice that on the right-hand side of the code build, the output artifact actually goes right into S3 as well, right? Okay, so that's the output. So that is the artifact that I'm talking about. That is the program that's going to be deployed. Then code deploy says, look at that. There's something to be deployed. There's a new artifact waiting for me to deploy. So code deploy will grab that artifact, right, from, let's say, S3. And notice another call out, instructions from appspec.yaml file. Yeah, it's a different name, but appspec.yaml file is what code deploy looks at and say, okay, so who do I deploy this to? Which servers, right? And do I have to run anything, when I deploy it? Do I do blue-green? Do I do in-place deployment? What do I do? So all those instructions are in the appspec.yaml file. Then it gets deployed. Wow, okay? So it's very simplistic, but this is basically how a simple CI/CD workflow works. I hope that was clear. So this actually concludes my very first section of what is DevOps and what are the AWS DevOps services. If you have any questions, please do let me know. Okay, if not, let us go ahead and do a bit of an introduction of the sample that I'm going to be showing you, right? So I figure these concepts, if you're brand new to it, you may say, kind of sort of makes sense, but I think it's much better if you actually see it in action. So here we go. So I'm going to go into the overview of this particular project that I'm going to show you. So it's a full introduction to all the code services that I've just mentioned. And this is available online. AWS makes it available publicly online. So, after this webinar, you can go there to that site. I'll give you a link to it, and you could try this out yourself. But I think that this particular tutorial, right, that AWS has available is, it's short enough, and it's comprehensive enough to show you the DevOps process from the beginning to end. Okay, it's called the Unicorn Wild Rise. Okay, here we go. So this is the site. By the way, I have the link, underneath, AWS link you see at the bottom. Okay? So it's called the Unicorn Wild Rise project. Okay, and there is a website to it. Like I said, it's freely available. Right? Check it out. So I'm going to be walking you through this. So I actually did this and I captured all the major screenshots while I was actually creating the Wild Rise project. And we'll go more into detail, but it's actually a walkthrough of, look, code commit, code artifact, code build, code deploy, and code pipeline. Look at that, right? So that's the complete set of AWS DevOps tools that I introduced to you. Okay, so you're going to get to see the whole thing. Okay. But one thing to keep in mind, though, is that the way to approach AWS DevOps and its tools is to make sure that each of the components are working. Make sure that the code commit is working, artifacts working, the build's working, deploy's working, and once you know individually they're all doing its job, then you put them together using code pipeline. So, the entire automation from beginning to end comes at the end. Okay, but once you have it all set up, then all you do is, what they call it, wash, rinse, repeat, right? Okay, so you go through that cycle, right? Once you have it created, okay? But it does take, a little effort to initially create it, and that's what we're going to go over right now. So the project workflow is going to look a little bit like this. So you probably noticed that way on the right-hand side, okay, you have something called Cloud9. Now that's new. I haven't really mentioned anything about Cloud9. Cloud9 is an integrated development environment that AWS offers right from their service. Right? So you can have a full-fledged development environment, with the editors, the debugger, the files, folder structures, even access to terminals, right? That you can run AWS command line interface commands with. So it's very, very convenient. So Cloud9, we're going to pretend that this is where the developers are developing their code. Okay, so that's where they have their original source code, and that is going to be committed to code commit, right? Source control version management software, and that is going to kickstart the build process. By the way, it's going to be a Java application. Okay, and the Maven, which is required for creating the package for Java, is going to be in code artifact. Okay? And once the build is done, okay, then code deploy is going to get kickstarted, and that the Unicorn, the Wild Rise application is going to be installed inside one single virtual machine, which is EC2. Okay? Now, obviously, you can have multiple, but in our example, there's just going to be one. And this whole thing is going to be orchestrated using the code pipeline. So the end product is going to look something like that. It's going to look pretty wild. Okay, very colorful, that website. Okay, so that's what we're going to do. But I think this probably is a good place to take a short break. I think we've been talking probably close to an hour right now. So let's go and take a 5-minute break. And after 5 minutes, we'll return and we'll get started right away. Thank you.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
All right, everyone, welcome back. Okay, so let us get to the actual hands-on part of it, okay? So as I mentioned earlier, I have taken a screenshot, okay, of the actual the tutorials as I was going through it, okay? So so don't consider this to be like the entire, like, you know, from the beginning to the end. I'm going to be I have to actually skip some details. But if you're interested in doing that, like I said, you could go to that website. At the AWS workshops that they offer publicly is very, very detailed, and it's very good. So give it a try when you have a chance, okay? So the entire process of getting this wild rides, right, live usually takes around 3 hours, okay? But I'm going to do that in 30 minutes, okay? All right, so let us go ahead and start. The first step is the source control and the artifacts. So here we go. If we were to look at the workflow, this is basically what they have in there, right? So right now, the initial thing is step 0, okay, which is to set up my Cloud9 environment. Okay, that's basically what I'm going to do. Okay. So here we are. On the left-hand side, it's kind of small, but this is Cloud9. Okay, so Cloud9 actually has on the very left-hand side has the file explorer. So this is where, you know, you can just go ahead and download files, upload files, create files, you know, do whatever you want with management of files. Then in the right-hand side, it's broken down into top and bottom. The top part is the editor page, right, where you see, you know, AWS Cloud9, welcome to your development environment. That's basically where the editors are. So you could write your Java application, Python application, what have you. Then on the bottom part, which kind of looks kind of a little grayish, bluish, that's the terminal. This is where I'm going to be working with Git, right, to clone the repository that has the wild ride source code, and I'm going to kind of be making changes into them and pushing it back into the repository. Okay. And on the right-hand side of the presentation at the bottom, I've kind of given you an idea that yes, I've actually downloaded the wild rides source code. That's why you see the file structure there, okay? Where you have the source, the main, the resources, the web app, and then you see this thing called index.jsp, so that's going to be the top page, right? Initially, then you have, you know, pom.xml and all that stuff, okay? So I've already done that. I've already downloaded the Unicorn Java code. I've already installed Java in my environment, and I've already downloaded all the source code that I need. And if you were to go to the workshop, they'll give you a clear link as to where you need to do that. Okay, so that's the step 0, all done. All right, so next one. Now we're going to go into code commit. Now that I have, so you have to kind of imagine that Cloud9 is my own personal environment. So I'm working on the Mac right now, so it's as if I'm working, you know, I have an IDE, integrated development environment, inside my Mac, and I have my code in my Mac. But in order for me to deploy it, I have to upload that onto AWS. So the place where I'm going to synchronize all my source code is code commit. So if you know how to use GitHub, pretty much like GitHub, okay? So here we go. Just like GitHub, right, if you've used it, you have to create something called a repository. So the repository is where all your source code, you know, the stuff that you uploaded, you updated, is going to be shared with all the rest of your team. Okay? So we have to create a code repository. And here, creating a Unicorn web project repository, right? And initially it's going to be empty, already. So then after I created this, okay, I'm going to go back to my Cloud9 because that's where my local source code is. And I'm going to be committing and pushing, right, all the code into code commit. Okay. So although you don't see too much detail here, you know, you may be able to kind of you know, zoom into my slide here, but what I'm doing is I'm going to set up the code commit repository at the on the Git and say, okay, you know, I'm in Cloud9, I'm on the local repository here, right, for Git, and my remote repository is going to be in code commit. Okay, so I need to do that kind of setup, and then I'm going to push the content up into code commit. That's basically what I did. Okay. And after I do that, I'm going to confirm that yes, indeed, my repository on code commit actually has all my files that are important to me, right? So as you see there, I have the source subdirectory, I have the pom.xml. So that tells me that yes, I was successfully able to push the content back in. But also keep in mind that this is the process which is going to trigger the rest of the process, right? Remember, triggering, right? The pipeline starts with the source code, and code commit is going to be that trigger. All right, moving on. Next one. So after I have the source code synchronized in code commit, the natural thing to do is to build, right? But in order to build, because this is a Java program, it needs some tools like Maven. And this is where code artifact is going to come in, right? So I explained earlier what code artifact would do is, give me a more stable access to these external tools that I may need in the process of building. So I'm going to specify Maven, right? Because that's a major tool in code artifact. So let's take a look and see how we do that. So initially, what we'll do is we'll create something called a code artifact repository. Okay, so we'll actually create a repository. I have a unicorn package repository just created, and I get to select. All right, so which external tools do you need to actually have in here, right? So there is a pop-up screen that kind of comes in like a list, and then at the very top there is Maven. There it is, Maven Central Store. Okay, so that's where the Maven is going to be stored for me, so that my code build, when it needs it, it doesn't have to go to the internet. All it has to do is access the code artifact repository. There you go. And the package flow, so this is after it's all been set up, is telling you, hey, so now your code artifact repository is ready to go. So whenever you want to use Maven, it's there for you. Okay. Now, one thing we have to do is we need to be able to access that, right? One thing to remember about AWS is that for anything that you do, even the services like code build, if it needs to access code artifact, you have to give permission. So we'll talk about those permissions. And when we do, I'll kind of, point out once again, hey, this is making sure that now that we've created all these things, that the code pipeline, the code build, whatever we need to access, will have access. One thing that code artifact gives you is once you create a repository, it's going to give you a way to access the repository you just created. Not just you as a person, but a program that you may be using, right? Such as code build. So here, there is a way for you to connect to code artifact repository. And it's a very simple, copy and paste into a file called settings.xml file. So I actually created settings.xml. And then I copy the connection instructions right from the code artifact. Then all I did was test the connection, just make sure it's working, right? So right from the terminal, you see on the lower right-hand side, I actually have this slide for you. So there, right from the terminal, I have the Maven. I'm running Maven MVN space -s space settings.xml space compile, just to make sure that, as from a command line, that I can access these things, okay? And it worked, by the way. Okay. All right, so now I'm setting up the IAM policy. So IAM policy is identity and access management. Policy is about permission, okay? So remember I told you that, hey, code build is going to be accessing Maven, but the code build must be given permission to access that Maven, files that I just created inside the code artifact repository. So that's basically what I'm doing here. I'm creating IAM policy for consuming the code artifact, right? So I created IAM policy. And by the way, the tutorial gives you all the instructions on how to do this, right? All I was doing was just following instructions here. Anyway, just without going too much detail about what the policy looks like, take a look at it in the tutorial if you need more, information about that. Anyway, so that actually completes this part, which is the code artifact, right? Okay. Moving on. Now we're going to go into the very exciting stage of building and deploying, because this is where everything kind of comes together, right? Okay, so let's go and take a look at that. Looking from the project workflow, now we're right in the middle, the code build part of it. As I mentioned, not automation yet, right? As you see, everything is kind of manual, right? Because in order for you to automate, you have to have each and every piece working before you put them all together and to do the automation, right? So that's what we do. So now it's just going to be building. That's it, okay? If you recall in my earlier discussion about all these pipelines, is that there is some place where you store your artifacts, right? After every step, you're going to be outputting your, whatever the result that you have, right? So in building, yeah, you're going to have an artifact, which is the executable file. That's the most important part, isn't it? Because that's what you're going to be deploying. So here, cold build will naturally want to save into S3. So we're going to be creating an S3 bucket. By the way, for those of you that don't know what an S3 is, it's an object storage service for AWS. So you could store like massive amounts of data, and files inside this thing called a bucket. So I've just created a bucket. Right? At the very end, I created this thing called the unicorn build artifacts bucket. Okay. So that's what I did. Create S3 for cold build artifacts, create a bucket, as you see there at the very bottom. Okay, so the next one here then is, now that I have the bucket ready to go, now I'm going to create something called a project. Right? So cold build requires you to create a project statement. Okay, so what is a cold build project? Well, you specify all these components that you need to run your build. Okay, so specify the source as a code commit. It tells you, hey, where do I get my source code to do all this building? So I say, yeah, that's from code commit. Then I have to specify, okay, so once we have the source code, we're going to be doing all this work, and we're going to be, linking, compiling, creating packages and stuff. So what environment, that is, if it were a server, what kind of server would you like so that you could run all these things? So cold build actually creates a container image based on the instruction that you give it right here. So you specify the container image, what kind of environment, to run and build your build commands. Okay, so that's where you specify it. Then where do you output, right, your artifact? So we just kind of created a bucket. So here in this project, you're going to specify, yeah, it's that bucket that I just created, the unicorn bucket. Okay, so that's where we're going to be outputting the end product from this whole process. All right, so that's what I did. I created the cold build project here. But this is not enough yet, because if you are a cold build, it says, okay, so you told me that you wanted a Linux image, and this is where I get the file, and this is where I'll put the file. But what is it? Like, what is it? Python? Is it Java? Like, what kind of command? Like, what kind of tools? Like, what do you want me to do? All right, so that's the next step. Okay, so cold build is going to be looking for a file. By the way, it's all lower characters. A build spec.yaml file. Okay, so the build spec YAML file are the actual build commands, right, that you're going to be running. So it's a separate file, and it has to be in the root directory, wherever cold build is going to be looking at it. So you create a build spec file. Here, it contains instructions on how to build the application itself. Okay, so in this case, it'll be like Maven, right, commands and stuff. And then once you're done with creating a build spec YAML file, right, I'm still changing this in Cloud 9. That has to be reflected back to that thing that I saved in the code commit, right? So I'm going to be committing and pushing this new file into code commit. Okay, so that's what I did. I kind of pushed it over, right? As you see at the bottom, I have git push, right, back into the main branch in the remote origin. Next one here, then, right, so when you create a cold build in the process is going to ask you, hey, what permission are you going to give me? Okay, and there is a default permission that cold build is going to assign itself if you don't do anything. But remember, in our whole process, cold build, in addition to doing all the rest of the stuff that they need to do, they also need to access cold artifacts, right? So, and remember, we created the IAM policy, right, Identity Access Management policy for cold artifact. Okay, so we have to add that cold artifact policy onto the existing cold build policy. That's all I did here. All I did was I just kind of added one policy, the one that I just created, onto the existing cold build IAM policy. Okay. Then let's test it. Okay, so we're going to be testing this. We're going to test build. So there is a button, right? You go to that project and you click on that button that says start build. That's it. Okay, but what, if everything worked okay, how would I know, right? So there'll be two indications whether the build completed or not. I mean, there are others too. You could look in the log file, obviously, but one is going to the cold build is going to visually tell me I'm done. Okay, so if it errors out, it'll give you a bright red message that says error, okay? And if it's successful, it says, yep, I think everything's successful. But there's a second place that I'm going to look for, which is my bucket, right? Because if the build is successful, in my bucket, right, the output bucket, right, there should be a zip file in this case, okay, which is going to have a WAR file inside, okay? So if I don't see anything in the bucket, then I know something failed, right? Because in the end, the artifact is supposed to be copied to that bucket, right? So that's what I'm looking for. I'm going to look into the bucket. And in fact, on the screen on the left, so that is the build, right? But what you see underneath my words on the right hand side, so that's actually the S3 bucket, okay? And kind of hard to see maybe, but at the very bottom of that, there is indeed a zip file, right? So I said, yeah, succeeded, good to go, okay? By the way, one thing to make sure that you do, okay, is that I gotta tell you, right, I actually failed the first time, mainly because I forgot to commit and push my settings.xml file, right? So, and I said, oh my goodness, I didn't put that in there. Commit, commit and then push and make sure that goes into the code commit so that when code build looks for it, it sees all those, all the other files that it needs to connect to, code artifacts and stuff like that. So once we start to automate everything, we don't have to worry about it, about missing those steps, okay, like I did. But we're not automating yet, are we? Right? So individual steps, they're all manual. So I have to remember to do that. All right then. So now that we have the build working correctly, the next step is, yay, deploy. Okay, so deploy them. I have circles on two places because actually we don't have a virtual machine yet, right? So virtual machine, this time we're going to be installing this, fantastic WildRides application. So we'll create the platform, which is EC2, and then we'll use code deploy to deploy the artifact, the executable file or the jar file that's inside waiting, right, to be deployed on inside S3. All right. So the first thing we did in the tutorial was to create, in this step, is to create the EC2 instance. Okay. Remember the infrastructure as code, right? And in this case, the tutorial actually gives you a piece of YAML file that will create for you a VPC, virtual private network, and put in there one EC2 instance so that you can deploy into it, okay? So the infrastructure as code is something called CloudFormation inside AWS. So it's an AWS CloudFormation template. So template is a YAML file, and then I'm going to execute that, and in the end, I should see in the EC2 one server, right, that is ready to go. And it took maybe about, I don't know, about 5 minutes for the CloudFormation to kind of get everything, working. But in the end, yes, indeed, everything succeeded. As you see on my screen here, I have all the green messages. That's what I want to see. Greens are all successful. Created the VPC, created in the end the EC2. But the proof is in the pudding, right? So I went to EC2 and I looked and make sure that there was actually a server, right? And indeed there was. There was something called the Unicorn Stack web server. So there we go. So now the ground is set. Okay, so we have the server, we have the artifact. All we have to do is deploy it. Okay? That is to install it, right, inside the server, and that's what code deploy will do for us. Okay, so code deploy, just like code build, requires like a configuration file. Okay, and that is called the app spec YAML file. Right? Remember, the code build took build spec YAML file. In the code deploy, it'll take something called app spec YAML file. Now, app spec YAML file specifies the action to take during a deployment, such as, hey, where do I install this in? Right? Do you want it in containers? Do you want the EC2? Like what? Okay, so that, right? Then which program to install and where? Okay, so in the tutorial, this web server is going to have like several starting a server, stopping a server type of a script, as well as app spec YAML file. And once again, I forgot to commit and push. So I'm putting in here, you have to commit and build, right? That is to push it. And once you because I've added some files here, right? So, appspec YAML file is in addition to that. I'm still in Cloud9 working on it. So I have to commit that and push it to code commit, okay? And that is going to be used to, once again, you have to build it too, right? Okay, yes, we are in the deploy stage, but the deploy will take what was built previously, right? And because I've added the file to the source, now I have to go ahead and commit, push, then build, so that now I have a brand new zip file with those brand new files in there, so that the cold deploy can go ahead and take that and deploy it. So remember, right, to do all those things. That's why I have a screen here for you: commit, push, and then build. Okay, still manual, but that's fine. Now, cold deploy, right, needs permissions. Yes, right, because what's cold deploy doing? Well, it's going to access an EC2, and it's going to be installing stuff. Well, that's kind of scary, right? So you want to make sure that cold deploy actually do indeed are permitted to do that, and you do that by creating a IAM role, right, for cold deploy, right? So we're going to be creating a cold deploy service IAM role, and it's going to be assigned to cold deploy. Okay, as simple as that, yeah. Now, when we do deploy, it's a little bit more, little involved. At least the user interface part is a little bit involved in the code, let's say, build. So I kind of broken out a slide for you here. So initially, you have to create something called the cold deploy application. Right. So right at the top on the left-hand side, right, cold deploy application. So it allows to make sure that you have this, nice package that says, unicorn application, right, deployment. And it's going to have all the configuration, all the deployment information. That's all in one place, that you don't misplace. Then inside that application that you create, you have to specify something called a deployment group. Okay, so here deployment group contains settings, configuration during deployment, right? And then within the deployment group, you can do multiple deployments. So here I'm going to be creating one deployment, deploys to selected platform, EC2 in our case, that is specified in the deployment group. So that's this is how they all kind of relate together, these settings. Okay? But no worries, right? When you are setting it up using cold deploy, it's going to guide you through one by one in that order. So here I'm going to create a cold deploy application. I created unicorn web deploy application there. And that's all there is right there. So, and then you have to specify, okay, so is it in containers? Is it an EC2? So I select EC2 on premises. Yeah, you can actually install stuff in on premises too. If you are able to install a cold deploy agent inside your on-premises server, for example. Yeah, just on the side. Then the next thing, once you create the application, it's going to say, hey, you want to create a deployment group? Say, yeah. So, creating a deployment group, specify deployment type. That is it in-place deployment? Is it blue-green deployment? Remember I told you, right, those two different types of deployment strategies. Environment configuration, what is the role? And so you'll see right on the details on the lower right-hand side, okay? So those are some of the questions that you have to add in there. If you want to tag something, do you want a load balancer? So in our case, we're not going to have load balancer because we only have one server, right? But that's basically what you specify. Anyway, so agent preferences. By the way, agent can be installed automatically for you when the cold deploy is initially trying to contact the server. But in order to do that, the server has to be ready to accept that command to have the agent installed. But that I didn't actually have any problems with the Amazon Linux 2 that we're using on the EC2. All right then, so next one here. Now we're going to create a deployment. Yeah, we're getting pretty close to the end here. So create a deployment, specify which deployment group you're going to be using, and then from that place, you can just click on, say, deploy, right? Or you could do multiple deploys. So you see on the right-hand side, the orange button that says retry deployment. Yeah, you can just go ahead and take that deployment and like redeploy it if you wanted to. And once again, there are two ways that you can check whether your deployment succeeded. One, visually, as you see there, it says succeeded. 101 instances updated, succeed. Wow, great, okay? But how do you know it's really succeeded? Right, once again, proof is in the pudding. Go to the website and see if you can see this wild ride, website. So that's what I did. I took that EC2 that they created, and there is a public IP address. So I put that in the tab, and then sure enough, not too exciting, but it says, hello, unicorn world. There it is, okay? So now my web server is at least beginning, right, to show you that, hey, it's a unicorn wild ride website. There you go. Now, last but not least, let's now automate the whole thing. Now we know that individually everything's working. Let's put it all together. Okay, so here we're going to be working on the DevOps workflow step 5, which is the code pipeline. Okay. By the way, whenever I explain code pipeline, okay, in my other courses, I kind of explain it like an oil pipeline. Okay, so when you have an oil pipeline, you have a physical structure which looks like a pipe, right? A humongous pipe, and then you have an oil that flows through it. Okay, so code pipeline is like that. Code pipeline is an infrastructure. It's a logical virtual infrastructure, and your program runs through it. Okay, and the code pipeline is what helps move it forward, right? It says, oh, you got it on source, boom, let's move it to code build. Oh, now it's done building. Let's move the next process to code deploy. Oh, great, now it's all over, right? So it helps to move things forward. And if there's a hiccup somewhere, it's code pipeline actually have a way to contact the developer and say, hey, there was a major problem here, so please go ahead and fix it, type of stuff. So it has a nice feature to orchestrate things like that. Okay, so from the workflow perspective, that's where we're at right now. We got the individual parts, now it's time to put it together. So code pipeline is known as a orchestrator, right? It's an orchestrator. So it's going to orchestrate code commit, code build, and code deploy all together. So that's the job, okay? Now, because it's a pipeline, it's going to look like a little pipe, okay? So if you see on the right-hand side there, I've created 3 stages, okay, in the code pipeline. And it's very visually very pleasing. It's almost like, yeah, I'm creating a pipeline here. Okay, so the first phase is the source phase. The second phase is the build phase, right? And the third one is the deploy phase, right? So you can see they're kind of all green, okay? Because as soon as you finish creating the pipeline, it's going to run. I know, right? But I don't have anything new. But it's okay. Code pipeline says that's okay. I'm just going to run this thing. And you have to make sure when you create each of the pipeline components that all you're doing is you're pointing to the stuff that you've already checked. So the source, I'm pointing to code commit. On the build stage, I'm pointing to code build stuff. Remember the project that I created, right, using build spec YAML file. And then on the deploy, I'm just pointing to the application. Remember the deployment application that I created with the app spec YAML file. That's all I'm doing, right? So then it ran, okay? So now what are we gonna do is, okay, so you saw that website, it wasn't too exciting. So now we're gonna make it into the very colorful, the real stuff. So I'm gonna make changes in my Cloud9 into the index.jsp file, right? So then, then I'm going to commit, push, okay? So what happens now is this. When I commit and push, okay, the code pipeline says, oh, hey, there's something new in the code commit. I have to move it forward to, code build. Boom. And then next it goes code build. When it's that's done, it says, oh, I'm going to have to move it over to code deploy. And once that's done, it says, okay, I'm all done. That's what's going to happen. This is the beauty of the automation. Okay. So here, I'm checking to see, confirming the pipeline. Okay. So I quickly, right, as soon as I commit and push, I quickly go to code pipeline because I'm pretty excited about, whether if everything's going to work okay. Then you can see visually as it goes through the pipeline, it says, okay, I'm working on the source right now, good to go. I'm working on the code build right now, good to go. I'm going to go to code deploy right now, good to go. Okay, so this is an example where I was kind of like watching it and everything deployed okay. But once again, right, now I'm going to go back to my website and I'm going to refresh the screen. Okay, so let's see what happened. Okay, and this is basically what happened. Yeah, brand new. Oh, by the way, I had to upload an image too, right? So the image was inside the, everything was committed and pushed and built and stuff. So there you go. And it feels so good, right? To after you work all these components and once you automate it. Now, if I made other changes, it's going to reflect. The whole process took maybe about, I don't know, maybe about 6-7 minutes, okay? Because remember, nothing is really instantaneous, because there are some times that you have to kind of take into account, right? Because as soon as you commit to co-commit, there's going to be some time, not a long time, probably like, not even a minute, but for the code pipeline to realize, oh, there's something new. Then remember the code build? It took like 5 minutes, okay? And code deploy also took I think it took like 3 minutes. I don't quite remember how long it took. So you have to put those all together. But it's automated, right? And I could have done this like all day, every day, right? So every hour I could be making changes, and every hour there'll be like changes on the website. Anyway, so I hope you enjoyed that walkthrough to actually see the AWS various DevOps tools in action. Okay, and that's basically what I have for you. Okay, and as I mentioned, try it out. Right, so if you would need your own AWS account to do this, but the instructions are pretty clear about that. Okay. All right, so now that I'm finished with the main content part, I'll be open to answering any questions that you may have.
Thank you, Terumi. That was very informative. I know everyone is looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And now I'd like to give the presentation rights over to Remy, our vendor manager, to introduce our promotions and webinar-related courses.
Thank you, Tracy, and thank you, Terumi, for this insightful session. I believe everyone must have learned something new today, or would have been able to brush up their skills around the fundamentals of AWS Cloud. I would quickly like to take you through some of our hand-picked resources, which we think will immensely help in accelerating your AWS Cloud scaling journey. Well, this document here of sharing on my screen, this has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up here is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. All these courses are hyperlinked. Feel free to go through them post-event and check out the course descriptions, prerequisites, and the value it can add to you and your team's skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as informative and educational blogs. You can make the most of these resources to gain extensive knowledge on the AWS topics they cover. Next up, I am thrilled to introduce the AWS Skill Builder, a dynamic learning center featuring over 600 digital courses crafted by AWS experts. I'm sure most of you must be aware of AWS Skill Builder. What is unique about this platform are the engaging game-based learning experiences. So through AWS Cloud Quest and team-based competitions on AWS Jam events. If you're hearing these terms, Cloud Quest and Jam events for the first time, I would highly recommend you click on this button and you go to our AWS Skill Builder page. I'm sure you will be amazed to see what all the Skill Builder has to offer. They have set of these gaming experiences in practical real world scenarios, which makes it so easy to understand concepts, technology, and processes. And it makes it so interesting for the learner. And for organizations, it saves a lot of time on employee skilling and ultimately enhancing the efficiency and productivity. As someone at Netcom who values continuous learning, I'm confident that AWS Skill Builder will be a game changer for any organization looking to upskill their workforce on AWS technologies. I encourage you to explore the diverse range of digital courses and experiences it offers. You can simply, as I said, click on this button right here, learn more, and you can explore more about the Skill Builder and the pricing aspect of this. Moving on to the next offering. Our free AWS e-learning courses follow a self-paced training model wherein you get the liberty of accessing extensive course-related videos that are delivered by the AWS subject matter experts on the go. So these videos cover the availability on the device of your choice. So you can access them from your laptop, your tablet, or from your phone as well. There are more than 280 videos covering various AWS topics explained in a very easy to comprehend language. You can simply sign up for free, watch these videos, and make the most out of them. Also, here I would like to inform you that this session is being recorded. So, in case you want to refer back to any of the topics that the trainer might have covered in today's session, we will be sharing the recording link with you through emails, and also you can access it here by clicking on this button. So you have to download this handout for that, and then if you want to revisit any topic, you can just simply click on the access recording and you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch the relevant updates related to IT and business trainings on our social media handles. So please feel free to follow us on LinkedIn, Twitter, Instagram, and subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message, or you can leave a comment on our social media posts, or you can just simply email us at info@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. Over to you, Tracy.
Thanks so much for guiding us through that information, Remy. And now we're going to go ahead and jump right into our question and answer session. First question we have today is, what's the difference between CloudFormation template and CloudFormation stack?
Okay, well, thank you for asking that question. And so to answer that question, let me go ahead and kind of refer you back to what I mentioned when I was mentioning the infrastructure as code, right? Remember I said that, look, infrastructure code is almost like an application, right? So kind of imagine an application. So in the application, when the developers create it, they're created inside a source code. Okay? And then that needs to be built, right? Like compiled and stuff, just like we did with the wild rice. Then in the end, you got an executable, or as I said, the artifact. Okay. So with CloudFormation, it's just like that. So the source code equivalent of CloudFormation is the template. So the template is in the format, either your choice, JSON or YAML file. So that's like a source code. Okay. And in order for that source code to turn into the network and virtual machines and such, you have to build it. And the application you use to build is the CloudFormation, right? So you build your template, which is a source code, right, using CloudFormation, and then the output that you get is all the network and virtual machines that you wanted to have, and that is called the stack. So the stack is a collection of all the resources, like the network, like the virtual machines, and anything else that you've actually wanted to actually implement. And that grouping of that together is called a stack. Okay. So source code, template, right? The output, the stack.
Next question is from Sean, and he's asking, can we use CloudFormation template to deploy resources to another region and another AWS account?
Yeah, so that's a good question, right? So CloudFormation is very, very convenient, isn't it? So for example, the CloudFormation template that we used in this webinar, it created the virtual machine, it created the EC2 instances and all the and the virtual network is what I meant to say. Let's create the virtual network. It created the virtual machine and everything we needed to run this wild rice website. And in the tutorial, I deployed it in North Virginia. Okay, but what if I wanted to deploy that in Oregon? Well, what if I want to deploy in Tokyo? What if I want to deploy in India, right? Can I do that, right? So these are different regions, and the answer is yes, with a caveat, okay? So the caveat means that there are certain things that must be true for these CloudFormation templates to work properly to create the stacks in those regions. So it will depend, it's case by case, depending upon what type of resources that you're trying to deploy. But take, for example, something like an EC2 server, right? So EC2 server requires an image called AMI, Amazon Machine Image. And Amazon Machine Image is going to have all the software that you need, to have this web server running. But that AMI image, or Amazon Machine Image, is tied or anchored or locked into a particular region. So I need to make sure, though, that before I run this CloudFormation template in a different region, that there is a proper AMI available, so that when the CloudFormation, it's time for it to refer to an AMI in that, let's say in Oregon, that there is a image in Oregon that CloudFormation can find. Okay, so that would be some cautions that you have to pay attention to. There are tools called TaskCat that you can try your CloudFormation template in various regions before you actually release that to the to people and say, hey, go ahead and use it. And you probably don't want people coming back with all kind of complaints and say, oh, it didn't work on Oregon, right? So make sure that you test it first. So the answer to would it run on other regions? The answer is yes, but you have to be careful of these certain details. Now, the second part of the question is, would it run on other accounts? And the answer is yes, but once again with some caveat, right? So if you're a company that has multiple accounts, right? Normally, what you would do is you would manage that under one big umbrella called the organization. So within the organization, let's say you have like 10 accounts, okay? And if you have one CloudFormation template that you actually want to run on all these 10 accounts, right? There's something called stack set that you can create. So from one location, using one template, you can deploy into many accounts. Obviously, you have to have permission, right, in those other accounts to deploy those resources like web servers. Let's say you want to run, you want to actually deploy wild rides, right, to 10 accounts. Well, you don't want to be, obviously you're not going to be able to deploy that into the account that you don't own or you don't control, right? So that's the one thing. But if it's in the organization, it's most likely that it's in your company, and then your CloudFormation need to have access to those accounts. It's called cross-account access. Make sure you have that permission set. Once you do, it's like magic. It's pretty beautiful. You create a stack set in one location, you say deploy, and boom, it'll start to deploy on all those different accounts. Okay, so I hope that's helpful for you.
And let's take another question from Dan, who would like to know, can you provide more examples on integrating Jenkins with AWS DevOps?
Yeah, thank you so much. So I've used Jenkins before as well, and Jenkins is very, very extensible, let's say. Okay, and for those of you that's used Jenkins before, you probably realize that it has like tons and tons of plugins, and those plugins, there are many, many AWS plugins. So the answer is yes, right? Jenkins, you can definitely integrate them in various places. So you could, I guess, not I guess, but you can, if you wanted to, replace the whole code pipeline, right, with Jenkins if you wanted to. And you could work with code build, code deploy using Jenkins. You could use code commit with Jenkins. So yes, the Jenkins is highly integratable with AWS services. But not only that, okay, if you wanted to, let's say, run Jenkins, right, you need a Jenkins server, don't you? Okay, and normally what one will do is you take a EC2 instance and you install the open source version of Jenkins in there and you set up Jenkins. But with AWS, actually, AWS provides a way for you to make that more highly available. That is, there is a plugin on the EC2 that's just for Jenkins, so that you can have a master Jenkins server, and then you have the worker Jenkins server, just in case you need to do like parallel work or more work than you need. So if you want to implement Jenkins inside AWS, I'm not even talking about integration with any other like code build and stuff, just Jenkins, right? You can have it built as a very highly available version of Jenkins, which I think is like fantastic.
Once again, I want to remind you that as you leave this session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.